Bismillahirrahmanirrahim. Welcome to topic 8.6.2, Resource Allocation Graph Scheme. So this method is a deadlock avoidance algorithm for single resource. Okay, we cannot implement the maximum number like what we have discussed previously because this is specifically for one instance of resource type. Okay? So now we have a new age which is known as claim age. So claim age is a direction from thread I to resource J. Okay, indicated that process T, actually not P, okay, not PJ, it's TI. That thread TI may request resource RJ that represented by a dash line. Okay, so we look at this figure. So this is the example of claim age. Okay, so before we make a request age, that's mean from thread to resources. Okay, we need to identify all the claim age, okay, for the particular thread. Okay. So claim age will convert to request age when a thread requests a resource. Okay. So previously it may request, but when it's certain to request the resource, so claim age will convert to request age. Okay. So request age converted to an assignment age when the resource is allocated to the thread. So when a resource is released by a thread, assignment age reconverts to a claim age. Okay. So resources, we can conclude that resources must be claimed a priori in the system. So what does it mean by a priori? So a priori means that before thread TI start executing, all its claim ages must already appear in the resource allocation graph. So for example here, okay, thread T2, okay, the possible resource that it may request is R1 and R2. Okay, so this claim age must already appear in the resource allocation graph. So that is what it means by a priori in the system. Yeah. Okay. We look at this slide. Okay. So suppose that thread TI requests a resource RJ. So the request can only be granted. Okay, the request can be granted only if converting the request age to an assignment age does not result in the formation of a cycle in the resource allocation graph. Okay, so we look at the example. Okay. Okay, let's say T2 okay, this is the claim age for T2. Okay, so it may request R2. However, we cannot grant this claim age to be converted to request age and finally to assignment age, because if we granted T2 to from the claim age to become assignment age, like in this figure. Sorry. Okay. If we allocate this resource to T2, so we already change the safe state into unsafe state. Okay, then if T1 requests for the resource of R2, then it can cause a deadlock because it lead a cycle in this resource allocation graph. That's why we cannot granted the request of T2 towards R2 unless, okay, T2 release it request H towards R1. Okay. So we check for safety by using a cycle detection algorithm. Okay. So if no cycle exists, then the allocation of the resource will leave the system in a safe state. Okay. If a cycle is found, then the allocation will put the system in unsafe state. Okay. So in that case, thread TI will have to wait for its request to be satisfied. Okay. Okay, that is how the resource allocation graph. Okay, the most important thing in resource allocation graph is the claim age. We need to predict, okay, all the possible requests, all the possible resource that will requested by the thread. Okay, so that's all for the resource allocation graph. Thank you for watching, guys.